For a long time, Hollywood has been obsessed with world-ending disasters. From earthquakes to giant floods to a giant moon monster? I don't know. But one topic has been particularly popular: asteroid impacts. Of all of the possibilities, this one seems like it could actually happen, especially since we know it has in the past. Luckily, we've gotten pretty good at tracking the location of asteroids in space. But even still, if one large enough were to be heading toward Earth, it would mean almost certain extinction for most of life on Earth. So what could be done to save us? Many ideas have been thrown around: aiming a laser at it, hitting it with nuclear weapons, strapping a rocket to it. But recently, one idea was actually tested. The DART mission, or Double Asteroid Redirection Test, was a successful mission to crash a spacecraft into an asteroid to attempt to redirect its path. The idea for the mission was to see if slamming a spacecraft with enough speed into an asteroid would alter its orbital trajectory enough to miss Earth. The target in question was an asteroid named Dimorphos. It's about the size of a stadium, roughly 500 feet in diameter. The reason they chose this asteroid in particular was because it was orbiting around an even larger asteroid named Didymos. This actually was a huge cost-saving factor for the mission. In order to observe the effect the collision had on an orbit around the Sun, a second spacecraft would be needed to measure the change in the orbit. With a much smaller orbit around Didymos, we are able to use telescopes on Earth and in space already to measure the effect. No need to worry though, neither asteroid is or was anywhere near being a threat to Earth. The spacecraft was about the size of a vending machine, designed with the sole purpose of being destroyed. It launched out of California in November 2021, where it embarked on a nearly year-long journey to reach the asteroid. On September 26, 2022, the spacecraft crashed into the asteroid successfully at a speed of 14,000 miles per hour. How was it able to hit such a small target from so far away? Well, we've gotten pretty good at matching the orbits of small objects where the spacecraft needs to make a gentle approach as to not damage anything. So in comparison, a spacecraft that's only job is to slam into an object as fast as possible is relatively easy. The team working on the DART mission had the spacecraft make slight course adjustments all the way up until an hour before impact. They were actually aiming it at the larger of the two asteroids because they couldn't even see the small one at first. At T-1 hour, the spacecraft started making adjustments autonomously, using its onboard camera to aim itself directly at Dimorphos. The spacecraft was able to take highly detailed images all the way up until impact, when the signal went dark.
3, 2, 1. Oh my gosh.
Oh, wow. Awaiting visual confirmation.
All right. Let's see. We got it? Waiting.
And we have impact.
Telescopes on Earth, as well as the James Webb Space Telescope and Hubble, all observed the results of the impact. Originally, the small asteroid was orbiting the larger asteroid once every 11 hours and 55 minutes. In order for the mission to be considered successful, they wanted to cause the orbit to shorten by at least 10 minutes. After the impact, the orbit had shortened by 32 minutes, so it was a huge success. It doesn't seem like much, but if we caught an asteroid on a collision course with Earth early enough, maybe 5 to 10 years before impact, it would only take a small force like that to divert it enough to miss Earth entirely. Luckily for us, we have logged many asteroids and none of them are a threat to us in the near future. Still, knowing that we have a plan that could work if an Armageddon-style threat were imminent is very comforting. Thank you so much for watching. If you enjoyed it, please don't forget to like and subscribe, and let me know if there are any topics you'd like to see me cover in the future.